A continuous deployment pipeline operates on momentum, right up until a single syntax error instantly halts the entire system. When that barrier drops, development stops. Engineers are forced to abandon high-level feature work to manually parse through terminal logs just to locate a missing bracket or a typo. This creates a repetitive troubleshooting cycle known as the pipeline janitor anti-pattern. Skilled developers spend hours cleaning up routine build failures instead of writing me code. To eliminate this manual friction point, I built Duo AutoHeal. It is an architectural solution designed to autonomously intercept and resolve these pipeline failures the second they occur. Instead of requiring a human to read a monolithic wall of text logs, Duo AutoHeal translates the failure into a structured JSON payload. JSON, or JavaScript Object Notation, is a lightweight data interchange format that relies on strict, predictable rules, making it easy for machines to parse. Effective DevOps requires moving away from passive chat interfaces, where an engineer manually pastes an error prompt. The system must transition to active, event-driven agents running on a serverless architecture. By removing human intervention at the exact point of failure, the deployment velocity remains uninterrupted. The system repairs itself and queues the fix before a developer even realizes the build has failed. The automated sequence begins at the millisecond a repository pipeline registers a failed state. This failure status automatically fires an event-driven webhook outward from the repository. A webhook is a lightweight automated HTTP callback, transmitting data between applications upon a specific event. This pulse is caught by a serverless receiver hosted on Google Cloud Run. This receiver acts as the system's first contact point, securely capturing the webhook payload that contains the exact details of the pipeline error. Because this receiver sits on a serverless infrastructure, the entire interception system remains dormant. It scales from zero and only consumes compute resources when a failure actually occurs. This instant, event-driven architecture scales without accumulating idle server costs, making it more efficient than writing scripts that constantly pull the repository for status updates. The most obvious approach to processing these captured logs is also the most dangerous, routing raw, unfiltered pipeline data directly into a monolithic LLM. An LLM, or large language model, is an artificial intelligence system trained on massive datasets to understand and generate human-like text and code. Handing an unstructured AI model write execution privileges in a live enterprise repository creates an enormous operational vulnerability. Without boundaries, unstructured models risk arbitrary code execution, hallucinating fixes, or injecting insecure dependencies. AI cannot self-regulate with sensitive logs. The output is too unpredictable. To prevent this, we must physically and logically separate the analysis layer from the execution layer. True enterprise automation requires verifiable security boundaries embedded directly within the pipeline infrastructure. This brings us to the universal troubleshooter. Powered by Gemini AI, this architectural node sits right at the edge of the security boundary. Gemini AI is a family of multimodal large language models developed by Google, designed to process and reason across text, code, and images. We place one absolute restriction on this troubleshooter node. It is explicitly barred from writing code. Its only permitted function is to fetch the tail end of the failing log. It focuses strictly on the immediate crash output, ignoring broader repository history. Operating as a secure filter, Gemini scans the isolated log snippet, categorizing the specific error type and isolating the broken file. The AI is then forced to conform its findings into a rigid JSON schema, explicitly preventing conversational text outputs. This schema demands specific key value pairs. The model must identify the exact error, like a syntax error, and pinpoint the target file path where it lives. Forcing the AI to map output to this strict JSON constraint neutralizes arbitrary code execution risks. By utilizing a read-only, structured output sandbox, we establish a strict safety boundary between the failing pipeline and the active codebase. On the safe side of this architectural boundary sits the remediation agent. This is a strictly segregated execution node. The structured JSON payload safely traverses the security boundary, leaving the raw error logs behind, and delivers only the verified coordinates to the agent. The remediation agent parses this validated JSON data. Because it ignores all prior raw logs, it operates with absolute focus. The agent's task is precise. It uses the isolated JSON parameters to draft the specific, localized code patch required to resolve the syntax error. Once drafted, the agent communicates securely with the GitLab API to package and transport the proposed fix. An API, or Application Programming Interface, is a set of defined rules that allows different software applications to communicate securely and reliably. By decoupling the analysis model from the execution script, the system achieves autonomous code drafting without compromising repository integrity. This precise sequence results in the final output state, a brand new merge request residing securely within the repository environment. A merge request is a platform feature used to propose, discuss, and review code changes before they are integrated into a main branch. Inside this bot-generated merge request is the automatically generated ready-to-merge code fix. This introduces a final security checkpoint. The system never pushes this fixed code directly to the main production branch. The proposed patch is intentionally quarantined within the merge request. It is fully pre-verified by the pipeline rules, structurally sound, and is simply queued up waiting for final human approval. We can trace a single line from the initial failure. Webhook triggers fire to Google Cloud Run, errors are filtered through Gemini's strict JSON schema, and the secure coordinates are handed off to the remediation agent. This automated sequence strips hours of manual log parsing out of a DevOps team's weekly workflow, keeping senior engineers focused on feature development. This integration methodology allows engineers to trust AI tools by enforcing strict, one-way data flows and automated verification. Duo Auto Heal functions as an active DevOps agent. It intercepts the failure, writes the patch,